Okay, here is the third and final main video for section 1.7, which is transformations of graphs. Now we're going to talk about reflections, which are a little bit more complicated than the other stuff that we've done, but not too bad. Anytime that you have a negative in front of the variable, it results in reflection. And there's two different spots where you can have a negative. If the A is negative, then the graph is reflected over the x-axis. And let me kind of explain why that is. Say this is your graph, okay? That's obviously the y equals x squared graph. Okay? If it's now negative x squared, basically what you're saying is instead of the y's being this, the y's are the opposite of that. Okay? So instead of having all these positive values of y, they're all going to be negative. Okay, so when that negative is on A, then you know that it's a reflection across the x-axis. If the negative is inside the parentheses, the graph is flipped across the y-axis, but there's also an adjustment that we need to make in that situation. And we'll talk about that when we get there. Okay, so here we have y equals negative x squared, the one that we just talked about. You'll notice that I have the parent function drawn up there. Okay? If it is reflected across the x-axis, okay, that means that every point that's right there is now going to be down here. So it's going to end up looking like that. So that's an easy example. If you have an odd function, and in the last section we talked about even and odd functions. But for odd functions, the reflection across the x-axis looks exactly the same as a reflection across the y-axis. In other words, here's my parent function right here. If it gets flipped across the y-axis, the point goes from here to here, and from here to here. If it gets flipped across the x-axis, it goes from here to here, and from here to here. So either way it goes, it looks exactly the same. That's only for odd functions. When the graph has several transformations, the first thing you want to do is make your reflections, and then make all the changes from there. You can do it in the other order, but it requires a slightly different bit of thinking. Okay, so make the reflection first and then make your other changes. And you must rearrange the equation so that x is positive. Okay, and this is that little adjustment that we had to make inside the parentheses. And this is what I mean by that. Here we have this graph right here. Okay, and so if you notice, we've got a positive 3 right there. And a positive 3 generally makes you think that it moves left 3 spots. That's actually not the case. What you need to do is rearrange this formula so that x is positive. And that would look like this. Okay? Notice that if you distribute that negative, the x is still negative, but that 3 becomes positive. Okay? Just like here, that's positive and this is negative. So we haven't changed anything, we just kind of rearranged it. But what this means is different than what you thought. Okay? Not only do we have a negative here, whoops, let's go back. Not only do we have that negative, meaning that it flips across the y-axis, but that 3 is now negative, which means it moves right 3 spots, not left like we thought. So anytime that you have a negative x within that function, you must rearrange that equation to get the correct result. Let's take a look at another example. I want you to look at this one and I want you to figure out what our transformation is on your own. So pause the video and make the adjustment and see how you do. Okay, the change looks like this. Okay, we have a negative within that function, and then we have this. Okay, so all told, there's a whole bunch of different transformations on this one. it's reflected across the y-axis, it's left 4, it's up 3, and it's fat. Okay, so that's all of the stuff that we need to consider when we're making these graphs. So now you have a kind of an idea of how to understand these reflections. So let's take those last two examples that we did and let's actually make the graph. Alright? When you make these graphs, always keep the parent function in the back of your head. Whether you make a little drawing, whether you make a little drawing like this to see where the parent is, doesn't matter to me. Just make it light so that I know that it's not the regular, the actual answer. So first of all, our parent function, it's a square root function. What else do we know about it? Well, first we want to handle any reflections. It's reflected across the y-axis, so it's going to look like that. And then also, it's right 3 spots, so it's going to look like this. Okay, that is your final answer. Okay, our next one, maybe you want to take the time to pause the video and see if you can graph this one on your own. I'm going to start with the parent function. Make my reflection. Since the negative is inside, that means that the reflection is across the y-axis. I also know that it moves left 4 spots, so it goes from here to here. I know that it goes up 3 spots, so it moves from here to here. And then there's that a term that we have to address. 1/3 is less than 1, so that means the graph is fat. So I'm going to leave that there, but I need to make it fat. Okay, so that means instead of going through the 1, 1, it's going to go outside the 1, 1. That's what it ends up looking like. So, hopefully there's no questions on that one. That is the end of this video. Sayonara.